For the first time ever, Nvidia has become the most valuable company in the world.
If you type in the list of the world's largest and the most valuable companies, you won't be surprised to find the likes of Google, Microsoft, and Apple. But one name does poke out: Nvidia.
Nvidia.
A company worth more than Amazon, Tesla, and Netflix combined. Yet, if you ask the majority of the people what Nvidia does, you'll be met with a confused look. This is one of the most valuable companies in the world, yet it's relatively opaque compared to other big tech companies. Microsoft, they made Windows. Amazon, they delivered me my socks and apple slicer. Google, they answer big questions. But Nvidia, maybe graphics card?
We wondered how a company founded in 1993 to improve video game graphics turned into a titan of 21st century AI.
Simply put it, Nvidia designed chips, but so do hundreds of other companies. Then why is it that a company that was once almost out of money is today a giant octopus with tentacles reaching into almost every tech-related industry you can think of? Nvidia might not be a household name, but whether you realize it or not, you almost certainly use their products. In fact, it is the company behind companies like Netflix, Adobe, Kellogg's, Airbnb, and even NASA. So what is this company doing today that might change how we live in the future?
What applications do you see driving demand in the general purpose, which is like, that's going to be like the next big thing?
We're pushing right now called GPU computing, using the GPU for much more than just graphics.
Nvidia are the initial pioneers of the graphics processing unit, GPU, which are like the CPUs, but the catch is that unlike the CPUs, which solves problems sequentially known as serial computing, GPUs handle complex tasks in parallel, created to work with 3D images, moving characters, and playing sounds at the same time. For instance, when you play a game like FIFA, millions of pixels on the screen are recalculated after every frame. This requires hardware capable of performing extensive matrix multiplication and vector transformations laterally. But Nvidia was well aware of the even greater potential of the GPU in the tech industry in the years to come. In 2007, Nvidia launched a software toolkit called CUDA, a parallel computing platform and an application programming interface that allowed software to use GPUs for general processing. Prior to CUDA, programming on a GPU was a nightmare for coders, involving complex low-level machine language. However, CUDA made it significantly easier to write programs that could run on GPU using standard languages like C, C++, Java, and many more. This expansion meant that parallel processing power could benefit a wide range of applications beyond graphics, such as scientific simulations, data processing, and machine learning. At first, CUDA was primarily used for niche applications, but soon it revolutionized computing by enabling users in a different field to process large blocks of data in a parallel, even unlocking the true potential of the deep neural network behind today's artificial intelligence. The power of modern processing units is measured in teraflops, which indicate how many trillions of floating points operations they can handle per second. A modern CPU has around 24 cores, achieving several teraflops, while a modern GPU like the RTX 4090 has over 16,000 cores, offering significantly higher performance. In simple terms, Nvidia GPU were capable of delivering high-speed data processing for advanced operations, and CUDA enabled the GPU to operate. While hundreds of billion-dollar companies use Amazon Web Services, behind the scenes, all the processing is happening with Nvidia chips. These chips also power AI systems like ChatGPT and Firefly, and accelerate climate modeling and astrophysical simulations at NASA. And with CUDA having a significant influence in the global tech industry and being integral to devices, computer systems across various sectors worldwide, Nvidia has now a Teflon image, and even the biggest of the companies depend on Nvidia. But how did a company that was almost out of money manage to gain such a stranglehold in the entire tech industry? Hey, do you want personalized thumbnails for your YouTube videos that has a high click rate, or you want me to edit your videos and make it more engaging? Check out the link in the description. Born in Taiwan, Jensuk Wang moved to the United States at the age of 9. He earned an electrical engineering degree from Oregon State University and a master's from Stanford. And then he served as a director of Core Wars at LSI Logic and also landed a job at Advanced Micro Devices, or AMD, which was then the dominant microprocessor designer. It was here where he dreamed of founding his own graphics company. Later on in 1993, Fremont, California, when personal computers were just starting to gain popularity and major tech companies were investing heavily in the research and development of the PC, Jensen Huang saw an opportunity. At that time, computers were primarily functional without speakers, microphone, videos, or any other advanced graphics. Multimedia use in the computers were practically non-existent, but was slowly entering the market as games transitioned from arcades to home consoles. It was then that the three founders, Jensen Huang and his friends from Sun Microsystems, Chris Malachowski and Curtis Prime, decided to make 3D graphics cards for video games and start a company at Denny's. Leveraging their connections from previous experience at companies like LSI and Sun Microsystems, they successfully secured $20 million in venture capital from Sequela Capital. With the funding, Nvidia released its first chip, the NV1, in November 1995. It was an innovative piece of technology featuring both 2D and 3D graphics that could be used for video processing and audio wave processing. It was also equipped with a gaming port designed to replace 2D graphics card in the market. But despite its impressive features, the NV1 failed to gain market acceptance, and out of expected 250,000 unit sales, only 1,000 were sold, forcing Nvidia to cancel the development of the NV1 successor and lay off significant portion of its staff. With just 1 month of payroll left, Nvidia's founder went all in on the development of Riva 128, or the NV3, the world's first fully accelerated hardware for rendering 3D graphics. Launching the Riva 128 was make or break for Nvidia. This real-time interactive video and animation accelerator became a groundbreaking GPU, outperforming all competitors by integrating 3D acceleration in addition to traditional 2D video acceleration. Unlike the NV1, the Riva 128 was priced competitively, selling 1 million units within 4 months, which was incredible compared to NV1's meager 1,000. Less than a year later, Nvidia shook up things again with the Riva TNT, doubling the render speed and boosting memory by twice the amount. This release officially established Nvidia as a major player in the tech industry. On January 1992, Nvidia went public, bringing in more money and buzz. With the funds flowing in, research and development proceeded at full speed, releasing chips one after another. The fifth product, GeForce 256, was another sensation. As the world's first programmable accelerator, it made waves in the multi-billion-dollar video game industry and was the largest chip ever built. The GeForce was so impressive that it caught Microsoft's eye for the next big thing, the Xbox. And the rest is history. This partnership not only boosted Nvidia's popularity but also came with a $200 million advance, solidifying its place in the tech industry for years to come. And in the future, Nvidia would take down AMD, becoming the world's most valuable chip processing company. But there was one key decision that made Nvidia strive while other businesses were failing during the dot-com bubble burst: by making Nvidia fabless. So it's clear that Nvidia makes chips, but what if I told you they actually don't? Nvidia doesn't manufacture its own chips, so why do people call them chip makers? This is an example of being fabless. Fabless meaning that they don't own any chip factories, they just design their chips and send it to manufacture. Surprisingly, this isn't unusual in the tech industry. While it used to be common for companies to both design and manufacture their own chip, handling every step of the process was tough and expensive. After the 1980s, non-competitive manufacturing partners like TSMC began to rise, leading tech companies to adopt their fabless model. Prominent businesses such as Nvidia, AMD, Qualcomm, and even Apple, despite their vast resources, outsourced their manufacturing. This enabled them to focus on design and sales of their hardware. Companies with fabless model benefit by concentrating their research and development resources on the end market, while specialized foundries, typically in Taiwan or China, produce their hardware very cheaply due to the economies of scale. Nvidia has been fabless since the releasing of their first product, the NV1, and has grown by sticking to this model ever since. Due to this very reason, Nvidia was able to survive the 1999 dot-com bubble crash. This has allowed Nvidia to focus on designing better chips and change the landscape of the whole gaming industry. Nvidia has consistently pushed the boundaries of gaming industry, repeatedly introducing world to newest and the most advanced technology. From efficient rendering techniques to AI-enhanced graphics, all innovations throughout the past 2 decades have redefined visual realism and seamless gaming experience. Gaming tools such as automatic game optimization and in-game overlays to Nvidia's investment in cloud gaming services has enabled high-quality game streaming from remote servers, setting benchmark in terms of accessibility and user experience in the gaming community. One significant breakthrough came with Nvidia's introduction of real-time ray tracing in the gaming through its RTX series GPUs. Before 2018, Nvidia was releasing the GTX microprocessor. The GeForce GTX series graphics card are designed to enhance PC gaming. However, beyond gaming, graphics cards have a broader range of applications, including product design, architecture, energy exploration, and scientific visualization. And in such areas, RTX cards excel, whereas GTX cards might not perform as well. Ray tracing of RTX translates 3D shapes onto a 2D screen and estimates lighting effects effects with shaders more realistically, offering high accuracy in dictating how light interacts with virtual screens. Autodesk Arnold and Adobe After Effects are examples of famous professional rendering applications that use ray tracing. Before ray tracing, the inherent limitation in the GTX card was having a hard time tracking exactly how light should travel and bounce within a certain scene. Ray tracing does a much better job of this, setting a new standard for realism, performance, and accessibility. And you probably have been enjoying it without knowing it for years. If you have seen any movies featuring CGI effects, it probably has RTX. This company, which operates with a $1 trillion scale, generates 50% of its revenue from its core business of designing graphics cards. The remaining 42% comes from its computer and networking segment, which are revolutionizing the tech world once more. These segments include AI-based data center platforms, high-performance computing, and accelerated computing. To put it simply, they are involved in self-driving vehicles, processor for cryptocurrency mining, and Jetson technology used in robotics. Nvidia has always been a trailblazer, significantly ahead of its competitors since its entry into gaming market in the mid-90s. Similarly, when the automotive industry saw a surge in interest in autonomous driving in the late 2000s, Nvidia again recognized a market opportunity to provide the necessary hardware and software for this sector. In 2015, the company launched the Nvidia Drive PX platform, a development kit designed to help automotive companies to build self-driving cars. It soon released other models like Drive PX Xavier with very low power consumption of 30 watts and Drive PX Pegasus for level 5 autonomous driving. These platforms leverage Nvidia's expertise in the GPU technology to power deep learning and AI in autonomous self-driving. It is able to process data from multiple sensors including camera, lidar, radar, ultrasonic sensors, and provide the immense computational power required for real-time data processing. That enables autonomous vehicles to efficiently perform complex tasks such as computer vision, detection and tracking, and sensor fusion to precisely understand the vehicle's environment. It also provides tools and libraries for building autonomous driving applications and implementing deep learning algorithms. Nvidia has continued to innovate, developing more advanced versions of Drive platform and partnering with leading automakers and tech companies such as Tesla, Volvo, Audi, and Waymo, a true revolutionary in autonomous driving arena, making self-driving even seamless. Nvidia was named the Autonomous Grand Challenge winner at the Computer Vision and Pattern Recognition conference this year, and also topped the leaderboard, outperforming more than 400 entries worldwide in the end-to-end driving category. Today's technological advancement, business needs, and market dynamics makes remote internet access crucial, pushing the cloud computing market to a new height. Currently valued at approximately $602 billion USD, this market is set to grow by 21% by 2030. Amazon Web Services, Microsoft Azure, Alibaba Cloud, and Google Cloud dominate the cloud provider market share. But how do they store all that massive data of its millions of customers? The only answer is Nvidia's GPU. Nvidia's artists use virtual workstation on Amazon EC for instances powered by Nvidia T4 GPUs to collaborate on VFX and animation content from anywhere in the world. BMW transformed its electrical vehicle production system by leveraging Nvidia's GPUs and Azure machine learning, fully automated quality control processing. Subaru Corporation uses the power of Nvidia's A100 GPU with Google Cloud Vertex AI to accelerate AI development for its advanced driver system. The accessibility, scalability, and collaboration that Nvidia has fortressed has revolutionized digital industries like never before. Nvidia undoubtedly carries the entire AI industry on its shoulders, since even tech giants like Google, Apple, Microsoft lean on its hardware to power their AI applications. It's no binary choice when it comes to Nvidia's supremacy in the powerful hardware design, but Nvidia is reaching for something grander. CEO Jensen Huang is now discussing about the future of artificial intelligence, omniverse, and generative AI. For years, Nvidia has been a leader in hardware, but at the recent GTC conference, it unveiled its bold new vision with the world's most powerful chip, the Blackwell GPU, boasting an astonishing 208 billion transistors to dominate AI computing by seamlessly blending cutting-edge hardware with powerful software. This isn't just a chip, but a platform for an AI revolution, empowering companies worldwide to build and run generative AI on trillion-parameter large language model.